Right. Good afternoon, everybody. It is 3:30, and let's get the webinar on the go. So let's see how many people do we have in here at the moment. Got about 100. Okay. All right. So I said afternoon. My name is Marius. I'll be facilitating the webinar today. But before we get to the guest speaker, I just want to share with you some information about the SAICE IT division. So the division is committed to driving innovation within the civil engineering profession by creating awareness and education opportunities around emerging technologies. Our vision is to reimagine the engineering workflows in the context of the fourth industrial revolution, exploring developments in artificial intelligence, building information modeling, and cloud collaboration and beyond. So our mission is threefold. So let's see if there's a chat in there. Okay, somebody's read AI isn't there. Okay, no problem. Let's continue. So our mission is threefold. It's to expose new technologies with practical applications to civil engineering profession, to deliver timely, relevant content that meets the evolving needs of our members, and to inspire a new generation of engineers by showcasing the transformative power of technology in infrastructure, with full regard to social, environmental, and economic sustainability. So the division is led by a dedicated team of 8 committee members who manage portfolios ranging from events, marketing, student outreach, to our sustainable infrastructure working group, which contributes to the SAICE infrastructure report card. So currently, the IT division boasts a strong growing community of about 863 members, the majority of whom are based in South Africa's key urban centres, so that's Durban, Joburg, Pretoria, and Western Cape. We encourage all SAICE members and also especially students to stay active in the division. And students are reminded that membership is free, provided that you renew annually and provide proof of your studies that you're registered for the year. Our webinars like the one today are shared across SAICE's broader membership to invite cross-disciplinary participation and grow awareness around how technology is shaping the future of civil engineering. Also keep an eye out on our social media channels for frequent updates and future events. All right, well, we're excited to have you to join us, and we hope today's session leaves you informed and inspired to explore new possibilities in your own professional journey. But before we introduce the speaker, just quick housekeeping. As you'll notice, the microphones have been muted, and that's going to remain such throughout the webinar. But please feel free to add your questions in the chat box. At the end of the webinar, we will have some a Q&A period where we can ask questions. And if there's in-depth discussions, we will then unmute the microphones as and when needed. Okay, so without any further delay, it's my great pleasure to introduce today's guest speaker. He's a true expert in the field of infrastructure and asset management, Dave Kutsia. He's over 37 years of experience in construction, municipal engineering, project management. He's built an impressive legacy across Africa, Asia, and Europe. He's also the founder of Daffron Consulting, where he currently leads strategic initiatives in physical asset management, helping clients to optimize infrastructure performance and improve long-term return on investment. So recently, Dave has taken up some pivotal roles as asset management specialist at a Queen Municipality, BIM coordinating manager at a major data center project in Austria, and is a key consultant on international development projects for organizations like the Asian Development Bank and World Bank. So his work integrates cutting-edge technologies and tools like BIM, Scan2BIM, and all ties digital information directly into sustainable infrastructure planning and asset lifestyle strategies. Lifecycle strategies. Dave is not only a certified asset management assessor, he also holds a unique blend of qualifications, including a master's in technology management, an MBA, and of course is professionally registered at EXA. So please join me in welcoming someone who has exemplified excellence throughout leadership in his field, Mr. Dave Kutsia. Dave, over to you.
Great, thanks, Marius. Just a quick comment, and in terms of being described as an expert, I always prefer the term specialist. My definition of an expert is an ex as a has-been and a spurt is a drip under pressure. So I always prefer to be called a specialist, because expert implies that you know an awful lot. And I feel that the longer I've been in the business, I kind of feel that I know less and less as I get older. But I suppose that's one of those things. So if you look at the title slide, you'll see that I also have Hein Velman listed as coming to talk with me. Unfortunately, he gave his apologies. He is unable to attend with me. So I'm going to be running this on my own. And then I just want to clarify the fact that I don't regard myself as a BIM specialist. I am more of an asset management specialist in the infrastructure field. So my background, as Marius said, started with municipal engineering on the construction and the design office side. Then I moved into project and program management, then engineering management systems. And then I've specialized over the last 15 to 20 years in physical or infrastructure asset management. So I tend to look at the BIM environment from an asset manager's point of view, and that gives me a slightly different way of looking at it than many of the other people that may have given presentations on this topic. So I hope that as a result of that, what I'm going to be talking about might be a little bit different from all the bits and pieces that you may have heard before over the last X number of years, because I'm going to be looking at things much more from a business case point of view and not from a technology point of view. And the main point that I really would like to emphasize as an outcome of this presentation is that the technology is fantastic and it's great and it's really is an enabler. But unless the technology meets the business case of the client, then it's all in vain. So one of the things that we do is we don't use BIM just because it's a cool technology and we can. We use it because we need it to advance the aims and objectives of the clients that we work for. So moving on into the slides. Sorry, I just need to get my... Right. Okay, so the importance of information. So based on my last comments and the fact that we need to focus our understanding and how we develop BIM in our industry, we need to focus on the client. What BIM really comes down to, and this is the information management or the information side of BIM, is the importance of information, not surprisingly. And really what we're looking to achieve here is to meet business needs of our clients. And the business needs of our clients are really going to focus around their business objectives. So ISO 19650, which we'll touch on a little bit later in some of the later slides, is really going to be looking at things from the point of view of a number of key documents that need to be put together to describe... Sorry, just give me 1 second. Sorry, my alarm system kept shouting at me. A number of key documents that need to be put together as part of your whole BIM approach that address various levels and various requirements and outputs of the organization. And once again, always focusing on what the client's business case is. Okay, and the importance of information and some of the things that it can do is really improve your the cost effectiveness of the work that we do. So if you look at some of those bullet points down the left-hand side, is reducing the cost of management due to through the improvement of how you manage your information. And I'll touch more on what that means a little bit later, because as an asset management specialist, That is one of the big things, and one of the reasons why I look at BIM and see it as a tool that we need to have in our arsenal in delivering services to our clients. Okay. Time, the 10 to 30% of the time that a facility manager searches for information. We want to really reduce that and put information at everyone's fingertips quickly and easily, because that is very much a cost saver. And then looking down on the right-hand side at that graph, the construction sector has very low productivity and growth. So that's the bottom line on-site construction if you compare that to manufacturing. And that's a really poor performance, and we really do need to improve the productivity of particularly infrastructure construction. So that's really focusing around civil and building work. And the way we do that is we need to look at this from a systems point of view. So looking up in the top right-hand corner of the slide, we look at what we call the systems view, people, process, and technology. And it's really, really important when we talk about a system that we understand what a system is in its holistic concept, and not mistake software for a system. Okay, so for an information system consists of people, process, data, software, and hardware. Those are the main system components of a software system or an information system. And a lot of people make the mistake of zoning in and focusing on the software and not looking at the other items. And the order in which I've said those are the order of importance. So we start off with people. People are the most important part of any information system and any system that we put in place. And they are also the first point of failure or the highest risk for us as organizations. So if we don't get the people part right, we start to have problems. And the next one is process. And this is one that is often missing from organizations. And as an asset management specialist, considering the information technology and BIM in particular as a supporting concept to improve how we do things, processes, standard operating procedures, documenting that, implementing it in a systematic way is often where we fail. And focusing too much on technology without dealing with the people and process is where we often go wrong. So one of the terms that we like to talk about in the business is BIM washing. And BIM washing, in my view, is really where what happens is where people come in trying to sell a software or a service around the BIM concept and really focus so much on all the wonderful things it can do and don't really think about the people, process, and the risk issues that can cause that to fail. And I have many examples where I've done work for clients where I've been asked to evaluate software implementations. And often the reason for that is the underlying comment from the client is that the software is not working for us. We would like you to recommend something else. And quite often I make them very unhappy by saying there's absolutely nothing wrong with the software that you've implemented. It's the implementation process and the lack of consideration of the whole system from a systems perspective and focusing only on the technology. So going back to my very, very first comments about we really need to see this as a business use case. So what is a use case? Because now I'm using information technology language. And the images at the top of the slide are really directly orientated towards BIM. So a use case defined who needs which information, at what time, in which format, and which level of detail. And the results of the use case is a common understanding and integrated processes, inputs to the BIM execution plan, mapping of the industry foundation class schema, and I'll explain a little bit more about those later on, and the basics for your MVDs, which I'll also explain a little bit later on. But really what we're trying to do is to make sure that everything that we do in our BIM journey and in our BIM service delivery is directed towards a systematic approach to improving our client's business. And as an asset manager, that is always my focus when I'm talking BIM. Okay, anything that we do or can do or spend money on that doesn't advance our clients' business objective is a waste of time, a waste of money, and is going to make them very unhappy. And I think this actually happens a lot more often than we would like to admit. So just expanding on the idea and then just bringing in a few other concepts and things that I'm sure many of you have heard many, many times before, we talk about the digital way of working, DWOW. Digital way of working is really using digital tools to automate and integrate our work to make it more effective and productive. And BIM is very much driven around that. And a lot of the standards and processes that have been put together by particularly international bodies are designed to move away from the idea of BIM as a software solution and into, once again, a system solution designed to improve efficiency, quality, profitability, and performance. And that is always a journey. And that's another asset management concept that really links in very well with BIM, is wherever you are in your journey as you seek to improve over time, you're never going to go from step 1 to step 10 in one easy step. You really need to do this one step at a time, and you need to understand and create a solid foundation to build your advancement as you go forward. So some of those steps there, we look at how we used to do things, 2D using Excel and 2D CAD drawings. Then we started moving into 3D drawings using tools like Revit and the Bentley Systems solutions and GIS, and things started becoming a lot more effective and efficiency. Then we start talking about BIM. And just for the record, when I talk about BIM, it's not only about buildings. So it is a bit of an unfortunate fact that BIM stands for Building Information Management, but a lot of us like to use the term Better Information Management, and we really want to focus on the built environment in all infrastructure. So it's not only, it should not only be used for buildings, but it should also be used for all different types of infrastructure, and can be. Then as we move up the maturity ladder, we get to the common data environment where we share data, and there's different ways of doing that. Then we start getting into automation and then connected data. And I'll talk about that in the next slide a little bit more. And then we start getting to generative, and then we start getting into our whole AI ideas, and who knows where that story is going to lead. But the top 2 or 3 steps of that item really are provide the foundation to talk about the digital twin. So this is another idea that I'm sure you've all heard a lot about, and I'm not going to go into a lot of detail because we don't have time for that. But what a digital twin is a digital model of the real world out there. So on the left-hand side, you see we've got the physical world. On the right-hand side, we have the future physical world where we want to get to, because everything is always about improvement. And that is linked by the digital twin in the middle. So if you start at the top left-hand side, we talk about data capture. So we want to capture data around what we really have. And from a BIM perspective, there's 2 angles to that. If it's new capital works, we can do that in our geometric models, or starting off with our geometric design models. If it's old existing data, then we've got the scan to BIM concept that comes into play, where we can do point cloud scans of infrastructure or assets and effectively reverse engineer a 3D vector model of what those assets really look like out there. That then starts coming into the digital twin, where we describe what it is that we have. And there's a lot of extra items that come into there. And that's something else I'd just like to, I would like to focus on and ensure that we don't overlook, is that, and I'm going to touch on that in a couple of slides later, we're not only talking about geometric modeling, we're also talking about the information attribute data that can get attached to each item of that model. So that's how we describe the model in a level of detail that is appropriate to do the predictions and make the decisions that we really want to. So this is where the digital twin starts to become powerful, is that we can use our in-depth understanding of the real world and we can use that to predict and to make decisions about how we want things to change going forward in any way. And that leads us to being able to prescribe and make decisions on changes that we want, whether it's an improvement or an extension or anything like that. And that change then comes back to the physical world, and the cycle goes around again. So that in a nutshell is perhaps a dumbed down idea of what the digital twin, and that area of endeavor, as I'm sure all of you know, is advancing at a terrific state as the cost of gathering real world information out in the field and transmitting it back to our digital models becoming quicker and cheaper every single day. Okay, then going back to practical BIM, was it? Because we've always got to keep it practical. So this is now, once again, just to emphasize what I said earlier, this is really, I'm talking with my asset management hat. And practical BIM is an information system and the perfect way to cross the commissioning line between the capital and the operating phases. And what actually happens as an asset management guy who's very focused on the O&M phase of a project, I often has traditionally been very frustrated by the amount of data that gets generated during the design phase, and which does not get translated effectively across into the O&M phase. So when BIM first started sort of getting on everyone's radar and we started using it, and even today, particularly in South Africa, a lot of the focus is on the geometric modeling and clash detection and all those wonderful and good things. The design development phase, where we use clash detection to make sure that all our different services work together properly. And whilst that is a hugely beneficial capability, particularly in complex assets, like, for example, things like data centers or hospitals, it's not the only thing that we can use it for. So all of the data that gets developed, traditionally what has happened is all of that data at the time when we commission and hand over to the O&M team, we tend not to make that information available to the O&M team. So that stays with the capital and the projects guys. And what happens is the O&M team goes out and starts from scratch building all the information. And that is an unnecessary waste of time, effort, and money. And so one of the big things as an asset management guy that I would like to see is that we use the existing embedded systems that we're using in the design phase and that have produced a huge amount of data, and translate that data across the commissioning line into the O&M phase. So one of my colleagues in the past had a lovely way of saying it. It says, as design engineers and construction people, we have a tendency to get really excited about the design and construction phase. And then when that starts coming to an end, we sidle up to our client, slip the keys in his pocket when he's not looking, and rush off to the next new job. And we don't show much interest in what happens after the commissioning phase. So in order to change that and to integrate, an integration of different processes, another huge focus from an asset manager's point of view, there's a number of things that we can do. We can use the already embedded systems in the capital phase, and all of those tools already have the capability to do the data transfer across the commissioning line into the O&M phase. But what we need to do is look at it from a systems point of view and ensure that from an organizational perspective, that we're actually doing what we need to do to maximize the value of that data and information. So we have to sell the value proposition. We need to get leadership buy-in. We need to build in and embed the processes. So that's the people in the process side. We need to extend the data and make sure we understand what data we need to embed within our models and how to transfer that across in a way that is standardized, that can be used going forward. And then we need to translate that data into the computerized maintenance management and enterprise asset management systems. And then we need to create the feedback loop. So those of you who are familiar with ISO, any ISO standard is built on the Deming cycle, which is the plan, do, check, act. And the whole concept behind that is you plan to do something, you do it, you evaluate what you've done, and then you carry out actions to improve that cycle going forward. So that's your continual improvement process. Just a very, very quick slide on BIM, the 3D up to 70, 80. So these are a couple of slides. They're probably getting a little bit old now. But when we talk about BIM, the obvious one that comes to mind is the 3D idea, so the 3D modeling. And that was a huge step as someone who's been around for over 37 years in the business. The step from drawing things on plastic film using wire pens to using 2D CAD was a very big step that we had to make, and it took a lot of people a long time to make that step, including myself. Even as a youngster, I started off drawing with pens on plastic film, and I was very much involved in rolling out analysis, software analysis solutions. But it still took me quite a long time to make the move from a good old-fashioned drawing board to a CAD solution. Then the next step was, that lasted for quite a while, and then the next big step is when everything went from 2D to 3D. And that was quite a big step. And as I said earlier, I'm not a BIM specialist. I never really made the technological step from drawing in 2D to 3D. By that stage, I was already moved away from the hardcore design into the management levels and project and program management and asset management. So I've never really done a lot of work in terms of 3D modeling. But at the moment, a lot of people see BIM as 3D modeling. And whilst that isn't true, it is far from being the whole solution. And where this is going to go in terms of continual improvement going forward is then we talk about 4D, which is where we include scheduling in the process. And Marius mentioned a project I'm working on in Europe at the moment, a data center. And it's quite interesting for me to see how the hard technical guys are bringing or bridging the gap between the 3D models and how that translates into providing foundation information for really doing good scheduling. And then obviously estimating is actually easier to conceptualize from a 3D model, because a 3D geometric model with all the appropriate attribute data linked to it it's almost automatic to then start to draw out costing data and information from your 3D models. And then items that, to be honest, I'm not familiar with, but what we're seeing is going through to things like sustainability, facility management, which is something that I'm very, very interested, and even things like safety and operations. So this is where your whole BIM concept is going to develop over the X number of years. And a lot of work has already been done overseas and in different places. But interestingly enough, working on the project that I've just mentioned in Austria, I'm actually working for a UK-based contractor, and the UK are generally regarded as being highly developed in the concept of BIM and using BIM, and there are a number of legislative requirements in terms of, particularly when working for the UK government, how you should embed BIM and BIM processes and how you do things. It's been a requirement for 8 or 9 years already. I'm actually quite surprised by the lack of knowledge by a lot of people that I speak to over there. So if, as a South African, you feel that we're a bit behind the curve, take heart. We're not the only ones. A lot of the people who we think are way advanced to us are not always. Some of them certainly are, but certainly not all of them. Okay, so this slide about knowing what we have, for me as an asset manager, this is a big deal. One of the main quotes I say to my clients as an asset manager is, if you don't know what you have, you can't manage it. And for me, this is the crux of the intersection between BIM and asset management, and why it has so much huge value and so much more than most people are thinking about at the moment. As I said earlier on, I think a lot of people are focused on the idea of BIM being 3D modeling and clash detection, which obviously it certainly is, but it is far more than that and has far more potential to improve the efficiency and effective of how we deliver projects to our clients. and also how we can set up our clients to manage themselves way better than we do at the moment. So in order, knowing what we have enables us to make informed decisions. And a lot of what we talk about is making good decisions. Okay. So what do we need? We need to know what it is. And Unit Class 2015, some of you, I expect, have heard of what Unit Class 2015 is. It is one of a number of asset classification systems. It is run by the NBS, and I'll explain that a little bit in a few more slides. But the NBS is custodian, and Uniclass is one of the few asset classification systems that is actively managed. Every 3 months, they publish an updated list of all the different Uniclass data sets, and I'll explain those in a little bit more detail later. Then we need to know the extent, how big it is, how long is it, how many square meters, how many, what number of. And you can understand that if we are developing, let's think of a data center as an example, because one of the more complex buildings, and buildings are generally more complex than a lot of civil assets, and data centers as building projects are particularly complex. If you've worked on one, you'll know how difficult it can be to shoehorn all the little bits and pieces into that. And from a clash detection point of view, we are constantly trying to fit things like fire equipment around electrical and mechanical trays and ducts. But it's fairly obvious that if you have a 3D model, extracting from that the extent of every item within that model becomes pretty much an obvious thing that you can do. So you know the volume, the square meters, the length of every single asset. But before you do that, the first point, we need to identify what all the different asset types are. Now, tools like Revit, for example, from Autodesk and all the other major BIM authoring tools, all of those already have the capability to build in, and things like Uniclass and some of the other asset classification tools are already built into those. So if you want to start to capture the attribute data, all the capability to do that is already in those tools. And to me, that is a powerful thing that we need to make use of, because it's an immediate benefit that we can gain very, very quickly at very little extra cost, because we've already paid the licensing fees for that. One of the big things, beg your pardon. One of the big things that as an asset manager, I always want to know where everything is. This is probably more important in civil infrastructure than it is in building infrastructure, but it's also important in building infrastructure. Obviously, if you have a detailed geometric model, you know exactly where everything is to within millimeters. What is its condition? So this is more of the downstream side. And then we start to talk about priority. So this is moving away from basic BIM and certainly the design construction and into the O&M phase. I want to know what the priority is, and I want to know what the condition is for every single asset, because that allows me to make informed decisions about where I apply my limited resources. So this little graphic down the bottom left-hand corner, during the design phase, the focus is on the geometric data. In other words, what is the shape of the item? Where is it, and how does it fit in with each other? And we don't focus too much on the attribute data. As we move into the construction phase, the importance of the geometric data, not the extent, but the importance tends to drop, because we've already set it over here. There will be a certain amount of as-built stuff that we need to worry about. But in the construction phase, we start to focus more on the attribute data, particularly for your MEP, mechanical, electrical, and plumbing assets, which are really important. And then as we get into the operational phase, the geometric becomes almost like, yeah, we've got that. Everything is now in place. We really spend a lot of time focusing on the attribute data. Okay, and if you look on the right-hand side, this is a real-life example of a building facility. It's a hospital. And with a fully realized BIM model, you can see how you can extract the different services, whether it be plumbing, HVAC, electrical, or any of the other services. So the ability to leverage that information that has been generated during the design phase into the construction phase is very, very, very powerful, and we need to make absolute maximum use of everything that we have. So I'm not going to spend too much time on these things, but I just want to go through open BIM and structured data. Some very important work has been done by a number of international organizations that have worked very hard to ensure that we standardize how we develop and exchange data, both at the attribute level and at the geometric level. So I'm sure this is getting a little bit more technical, but I'm sure most of you understand the idea of IFC schema, which is Industry Foundation Classes, which is an open file format used by BIM systems. And all of your BIM authoring tools, whether it's Revit or Bentley, MicroStation, or any other, will be able to talk to these formats and export and exchange data in these formats. And that is really important work, because it really does underlie how we transfer data between different systems. And that also goes back to your EAMS, CMMS solutions, which is, as an asset manager, I'm very interested in. So CMMS, obviously, as I mentioned earlier, being computerized maintenance management, and enterprise asset management systems. So the data that comes from your BIM authoring tools can be automatically moved across into your CMMS, EAMS solutions if you've set your system up properly. And then your COBE. COBE is your construction to operations building information exchange. This focuses more on the attribute data, which as an asset manager is what I'm really, really interested. So there's a number of BIM use cases, obviously design authoring, setting specifications, clash detection, construction planning, quality takeoffs. We've spoken about some of these already, preliminary budget estimates, energy analysis is something that can be built in as well, and then getting down to my area of interest, asset management and facility management. Just so people understand, I drew this slide for myself when I very first did it a couple of years ago, because you get all of these different terms and acronyms and things thrown at you, and you don't always understand what they are. So Uniclass, as I mentioned before, is an asset classification system that can be used to underlie COBE. So COBE is a structure for capturing asset attribute data for each of the different type of assets that you define in Uniclass, and a lot of that data and information. So those sort of things could be things like the model number, the serial number, the manufacturer, the kilowatt size, or the square meterage, or the paint specification, etc., etc. Those are all the different attributes that you might want to capture for downstream use during the O&M phase. So first of all, you need to break your whatever it is you're building into its components using Uniclass or OmniClass, or one of the other classification systems out there. And then you move that data into preferably a COBE standard data attribute structure. And COBE is a subset of Building Smart, and Building Smart is formerly the International Alliance for Interoperability, and that's an international organization which aims to improve the exchange of information between software applications used in the construction and facility management industry. So I think things like Uniclass is developed by the NBS, and if you're not familiar with them, if you haven't seen them, I suggest, if it's of interest to you, that you go and have a look. So it's National Building Specification. It's a UK-based organization that provides digital tools and services for construction specification and classification. These tools are enormously helpful for architects, engineers, and construction professionals in the creation, management, collaboration of building specifications and construction. Okay, so that slide is really just shows how some of these key international standards fit together. And what we're really trying to do is curate information, taking care of information in a structured way. So that second bullet point under the first heavy item classification, it's something I spend an enormous amount of my time dealing with. So one of the projects I'm working on right now, and I'll be doing it after this session and tomorrow again, is developing classification structures for infrastructure asset owners. things like location. There's a million other items that go. These numbers can go to hundreds of different attributes that you might want. And this information is managed through various processes, and this is where ISO 19650 comes into play in terms of creating standards in terms of the owner's information requirements, the asset information requirements, and the used to be employees information requirements, and the name has gone out of my head what it's changed now. And all of these form part of the BIM framework. So at the bottom, we've got this idea. This is how some of the COBie tables start to look when you start putting all the data into them. And what we're trying to do, as I've been saying repeatedly through the last half an hour, is that we ensure that everything is standard, that we do this in a standardized way so that people can interpret the data. And on the right-hand side here, these are the main tables that Uniclass uses. So complexes, spaces, activities, entities, products, systems, and elements. And because they are constantly updating and improving how these look, these numbers are already woefully out of date. The products is the big one. That's probably the last time I looked, and I haven't updated this slide, that was at over 8,000 different products. And by now that's probably closer to 10. I must actually go and have a look. And then just what are these different things within Uniclass? Now, bear in mind that I said Uniclass and the ability to capture Uniclass type data according to, they give you a list of what all the options are. So you don't have to work it out yourself. All of that is already built into most of your BIM authoring tools. So complexes describes a project in overall terms. The entities are things like buildings, bridges, and tunnels, activities, spaces and locations, which is particularly important in buildings. The one is an asset manager I'm interested, which is why I've highlighted this, are the different elements: walls, floors, roof, foundations, piers, decks. I want to know what all of these are because I need to manage those on a day-to-day basis during the O&M phase. Systems, what systems are in place. I'm not going to go into detail because that's a whole lecture on itself, the difference between elements and systems and products. But it is quite important. A lot of people get these mixed up. Then going through the information lifecycle, and I'm going to go through this quickly. We start off in the BIM process with our strategic planning, which we want to standardize as far as possible, and standardization applies to everything that we do. What are the information requirements? What do we need to know? What is the capability and who's being appointed by what? All of this is embedded in ISO 19650 in a very structured way. What is the information delivery plan? How are we going to generate the information and how are we going to do it? And I'll explain that in a little bit more detail in the next slide. What is the project information model? What is the asset information model? In other words, what does the asset manager want out when the project is completed? And then all of those things during the O&M phase used for your asset performance, and then using the continual improvement cycle concept, plan, do, check, act, we can go back into strategic planning for how we're going to improve that asset going forward or that facility. This is very much an ISO 19650 document, but Han put this together for us. And this is very, very powerful because it shows what are the requirements, what are the deliverables, what is the organizational level, what is the asset level, what is the project level. And it's very interesting to look at these three items and the tracks that it goes through. If you're delivering a project with no asset management, you follow line 1. So you have a project information requirement specification that gets developed by the appointing party. They will then develop the exchange information requirement that used to be called the employer information requirements. That's what I couldn't remember in the last slide. Then from there, you develop your project information model. Okay. However, if you're looking at it from an asset manager's perspective and not thinking about it in terms of project, you're going to follow line 2, which means what does the organizational require? And this goes back to what I say, it's really, really important to think about things from what the organization's business case is. What do they want to do with their assets? How do they want to maximize the benefit and value that they get out of it at the minimum cost? So there you start, what is your asset information requirements? And then what is your asset information model that pops out at the end of your project that you can then carry across into your C, MMS, E, AMS. However, the way you really want is to go through track 3, where you decide what does the business case require. Then it comes down to what is your asset information requirements to support the organizational requirements. What is the exchange information requirements? How does that translate into the project information model? And then how does that then go to the asset information model? So this is a much more integrated way of doing it. And you'll remember I said earlier on, as an asset manager, one of our primary objectives is integrating the thinking between various different silos within organizations. But in the context of BIM, one of the big things we're trying to do is integrate the thinking between the capital phase and the O&M phase, which we're generally quite poor at doing. So what are some of the deliverables? So that's in the column here. The exchange information requirement sets out managerial, commercial, technical aspects of project or how you're going to produce the project information and what structure and according to what standards and in what format. And we want to define that very, very carefully. If you don't, you will get data in formats that you can't cross-reference across your whole portfolio. And as an employer, you want always to have data in the same format and to the same extent and level of detail for all your different assets and from all the projects that you implement, so that you can consistently manage your portfolio across all its different aspects. The project information model is a single source of digital information related to assets developing during the design and construction phase, and your asset information model is related to assets to support the organization's asset information requirements and system. So whilst this sounds all very, very simple, and some of these documents are frightfully simple, they don't have to be complex. What we're trying to do is standardize everything in a systematic way so that we can use the information, we can roll it up, and we can slice and dice and do really fun data analytics. Now you can imagine when your asset base gets big, how important it is to have this all in a standardized way so that you can make good decisions, particularly with regard to constrained resource allocation. Just quickly, and I'm getting quite close to the end now, I'm only going to talk for probably about another 5 minutes. What are the BIM levels? The BIM level 0, no collaboration, 2D CAD only. This is what we were doing 20 years ago. Then we started moving into BIM level 1, where we used 2D and we started using 3D, but everyone did their own things in a different CAD. Common data elements is perhaps a little bit limited in that stage. We do start thinking about ISO 19650, but not in a holistic and integrated way. And basically each stakeholder works on their own data, but some sharing occurs. What is mandated in the UK for all government projects is what we call BIM level 2. So that's where what we call a collaborative BIM. Everything is done in 3D models with attached data built in, as I said earlier. Each discipline creates its own models, but models are shared in a common format. For example, the industry foundation class format. And then a federated model gets developed. So the project I'm working on as a BIM manager at the moment in Austria, what happens is every week on Monday, each of the disciplines, the electrical, mechanical, the fire guys, this concrete guys, the steel guys, the various architectural disciplines within there, they upload their latest model into a common a common data environment. In this case, we're using Autodesk BIM 360. There are many others out there, and different people have different preferences. Then what happens is one of my team will then federate that model, and what that means is he adds them all together and make sure that we're using the same coordinate referencing space. And then one of the things that we do is, one of the most important things we do is we use a federated model to do clash detection. Now what's happening as we get to the end of that project, clash detection becomes less and less important because the design development phase is finished. We're in the construction phase. What we're going to do is we're going to, at completion and at various intermediate points, we do point cloud scans and then check that against what our models to see whether we've met our tolerance requirements and everything is in the place it was intended to be. And now what's actually happening is as that work starts to wind down, my focus as an asset management guy again is hammering particularly the MEP guys, but everybody, all the different disciplines, to make sure that they create the attribute data that the client has required from them, and that is captured in the model so that it can be transferred at completion across to the CMMS, EAMS, and facility management solutions. What we're looking to get to in the future is level 3, which is what we call an integrated BIM. This is where everyone designs in the same model. So in level 2, the essential difference, each discipline works in its own model and then federates it every so often, usually once a week. In an integrated model, everyone is working in the same model. I haven't seen that happen yet, but that's where we're going to end up to. And that's why these open standards become quite important, because the different tools will want to be able to access that data. Going on to the hidden value, I'm not going to spend too much time on these things, but these potential values of using BIM, 47 to 65% reduction in conflicts and rework during construction. So as I said before, one of the things I do every week, well, not me, but my team, is when we create our federated model on Tuesday, my team will go through looking for clashes. And the software, the BIM software, authoring software, makes that very, very easy. You compare disciplines pairwise one at a time, and you look for clashes. Clashes, not all clashes are issues. Some clashes are expected. So one of the things I have trouble explaining to non-technical people is why the concrete and steel models are showing 2,000 clashes every week. And that is really because the holding down bolts in the foundation pads, those are part of the steel model, but they're embedded in the concrete. So in a simplistic way of looking at, the software will tell you that's a clash. You can exclude that, but the problem is we federate each week. So what we do is we don't exclude it, we just ignore it. And sometimes in clients who don't understand it get very excited when they see the dark red and the literally thousands of clashes shown there. But as we explain to them, we really do need those clashes because of the holding down bolts aren't in the concrete. That's not a good thing for keeping the building where it's supposed to be. Increases in project quality, reduction in risk and better predictability of outcomes, better performance of the completed infrastructure. All of those percentages are taken from the UK Government Cabinet Office, where they did some analyses of what, trying to assess what the improvements, and those are really big improvements. So 20% reduction in build costs by using BIM. So this at the moment is also focusing, as I said earlier, on the capital construction phase, but there's a lot more value to be extracted when we start thinking further down the line as we cross the commissioning line into the O&M phase, and that is what I try to champion going forward. And then a 30% reduction in cost over the life cycle of the building. Now that's a really big one, because if you look up in the top right-hand side, that little graph, one of the problems that we have is that we spend quite a lot of time during the design and construction phase trying to minimize costs. But generally, the total spend by the asset owner of the capital phase is about 20 to 30% of his total lifetime costs. 70 to 80% of his expenditure will be in the operations phase, and we tend not to focus enough on that during the construction phase. And that is the value add for the asset manager. And this little graph down here, what this is showing us is that what we're trying to do is get this constant improvement of information, increase in information that gets given to the client and the value that it has as we go through the inception, concept, detail, design to project construction and closeout. But what actually happens is we develop a whole lot of data and then we step to the next phase, we don't carry it across. So we keep having to do rework. And the difference between this and this constant improvement that you get with a properly enabled BIM approach is where these percentage improvements come from. All right, and then digital assets. I'm not going to spend too much time on this, but digital assets are assets in their own right. Okay, so what we're really trying to do is to add value to the life cycle of our infrastructure, not only by looking at the design and build and the O&M, by adding our digital assets into the mix to optimize both the design and build and the O&M phase, particularly by integrating these two, and this is the commissioning line I talk about. And what we're trying to do is maximize all of these things to include the value that we spoke about in the previous slide. Okay, embedding within an organization. How do we do this? We make it policy. So from a strategic point of view, and one of the earlier slides, I spoke about policy and strategy. How do you do this within an organization? And this applies to both the client asset owners and the service providers that provide infrastructure services to the clients that own assets. We need to make policies. We need to define what those policies look like. So the strategic side of things is very, very important, where we decide and make the rules of how we're going to work by. You need to have a digital transformation process that really defines how we move from BIM level 0 or 1 to BIM level 2 and eventually to BIM level 3. This little diagram on the right is courtesy of RHDHV, and this shows the interaction between the OPEX and the CAPEX and how our whole improvement plan works around. And I'm not going to go into any detail because I think I'm running out of a bit of time at the moment. And then this is my last slide, and I'm not going to spend too much time. I'm pretty certain most of you know what this is, but just in case you don't, how does BIM, what is the main driving ISO standard or SAN standard in the case of the South Africanized version of it? It's going to be 19650. And there's a number of documents. We've shown you 1 and 2. 1 is the concepts and principles, and 2 is the delivery phase of the assets. And there are a number of 3, 4, 5, and 6, some of which are out, some of which are still planned the last time I looked. And they cover different aspects of all of the things that we've been speaking about today. And that is my story. I hope I haven't droned on too much and been a bit too boring. But yeah, if we have any questions.
Dave, thank you very much. This was extremely informative. I'm sure everybody else, I see all the hand claps, so it's much appreciated. So let's move over to some questions. I think there's only one in the Q&A box. So Dave, you've mentioned that many of the challenges with BIM stem from the implementation phase. In your experience, what are the key factors or best practices that contribute to successful implementation of BIM on a project?
What I would say that would go back to the second to last slide that I spoke about, and that really comes down is to a couple of things that are really strategic. So in order to do that, you need to have a plan. So from a strategy point of view, you need to, and this is very much going back to asset management stuff. So what we're trying to do is we need to understand what the objectives of our organization are. We then need to create infrastructure asset objectives that align with the business objectives. And then based on those objectives, we need to develop a policy. So a policy is a high-level document that's not too long that really sets our own definition of what the rules of engagement are. They are normally decided by executive management, but hopefully based on a lot of data and input from the more operational level guys. Then once you've set your policy, then you have a strategy. And your strategy really says, this is what we're trying to do at a high level, and this is how we plan to do it. And then from there, you start to unpack your implementation plans, which go into all the detail and add resources to how you want to get this done. So when the big thing for me as an asset management guy rather than a BIM guy, so I'm an asset management guy masquerading as a BIM guy, I'm not a BIM guy. And that's why my perspective is perhaps a little bit different from what you might have heard before. I'm very interested in what comes out of this, and okay, I like cool tech, so I'll be lying if I said I'm not interested in what the technology can do unless it relates to what the business requires. I am actually. I love this stuff as well. But my job says I'm very much driven by how we relate what we require from a business point of view to what tools we need to put in place to get it. And then the only way you get that right is have a strategy, have an implementation plan. And then remember when I spoke about the systems view, how do you, from a systems point of view, implement this? And it really starts with getting all the people on board, selling the concept, dealing with change management, all those things engineers hate. But actually, and I hate to admit it, it really, really is important. All those, we call them soft issues in terms of change management and getting people behind it. But unfortunately, if we don't do it right, and I think as technical people, and I'm a hardcore techie myself, if we don't get those people and process things right, we will fail. And I think that's where in environments such as this, in these fora, we need to emphasize how important the people and process side are rather than the technology. So I would say drive it from the people and process point of view, and the technology will follow. I've had a number of cases where people, I think I mentioned it earlier, have criticized various software package and asked us to evaluate it. And my answer is almost always, it's not the software, it's the people in the process that have failed, the implementation configuration. I hope that answers the question.
I think it does. Thank you. There's a second question from Letu. So question is, can BIM completely eliminate paper-based workflows through common data working environments during the construction phase?
Okay, great question. And I have literally just before this meeting came from printing out a document on an A0 so that I can write on it and scribble and draw arrows from one place to another, because as you can see, I'm an old generation person who struggles to do things on small phones and handheld tablets. So there are some things that I really enjoy doing on paper and on whiteboards and drawing lines, particularly when talking to people. And that may just be because, I'm an old bugger who's been around for a long time, so that's my comfort zone. And the younger generation certainly are a lot better at doing it electronically. I think, but the correct answer is we definitely want to reduce paper-based stuff, because the disadvantage with paper-based stuff, it sits on your desk or in some storage facility, some filing room, and is not accessible by everyone. So one of the really, really important items with BIM is the CDE. So that came up earlier, you will see it in the slides, and that's the common data environment. And what the common data environment does is allows you to store every single item related to the project or the asset that's been dealt with by the BIM facility. So whether it is the geometric 3D drawings from Revit or MicroStation or whatever, or whether it's a specification document or a maintenance manual. In theory, all of those things we want to have stored in a central repository, because the word we use from an IT point of view, and I'm sure all of you guys know this as well as I do, is a single source of truth. So we want to make sure that when we talk about, like, say, for example, the specification or an asset is replaced with another one, that we have the latest user manual and specification documents. We don't want to be sitting there agonizing when the thing's failing and spraying oil all over the place during the O&M phase. Do I cut the red wire or the green wire, for example, because I don't know where it goes? We want to be able to very, very quickly draw the data and know that it's correct. And so your electronic data document management systems, which for us is normally called the common data environment, are really, really important. So I think the correct answer is that from a personal point of view, there will always be a little bit of paper lying around, but we really want to get to a digital view, because that's the way we can share information correctly, properly, with the proper permissions, with the proper updates, and ensure that we've got a single source of truth as and when we need it immediately.
Yeah. Excellent. All right. I don't see any other questions, either in the chat box or the Q&A. Oh, Q&A is a few more, yeah? I didn't see them. Let's see. All right. Matthew asked that, how would you link BIM requirements to a design build contract, specifically in light of the lifecycle cost being 70% OPEX cost? DB contracts generally aim to minimize capital cost, but generally there's a little input from the client into the long-term life cycle cost.
Generally, there is little input from the client into the long-term life cycle cost.
Yeah.
So that statement is a really, really, really important one. And as an asset manager, that is one of the things that I'm constantly try to change. So one of the way you do that is during your design development phase, you ensure that there are personnel from the operations and maintenance team involved in the design development phase. So one of the terms that we like to use and is, and I don't know if there's any quantity surveyors in the room, but they'll probably not be happy with me when I say this, but one of the terms that we use during design development is value engineering. And value engineering is an idea, and I've got a whole set of slides that I can talk to on that. But value engineering as practiced is not the value engineering that it should be. So what value engineering as practiced during the design development phase is, let's cut costs as much as we can. And what that normally means is that we cut costs during the capital phase at the expense of the O&M phase. And as you rightly point out, Matthew, if the O&M phase is 2 or 3 times the amount of money expenditure that it is during the capital development phase, surely that's a bad thing, and it absolutely is. So value engineering as practice is often not done the way it should be. And one of the things as asset managers we say, you will not do your design development unless the O&M guys are on the design development team. Because when someone says, no, we'll exchange this part for another part, particularly in the MEP, which is where most of the O&M costs arise, what's going to happen is that the maintenance guy is going to say, oh, please don't do that, because I know what's going to happen in 5-10 years' time when it all goes wrong. And as an asset management guy doing a lot of condition assessments, and my background is structural engineering, so it tends more to be on the fabric of the building. There are many times when I've seen things and I've walked around with the maintenance guys of a client, and I have actually said, they asked, well, why is this gone like this? And I said, honest answer, the design engineer needs a kick in the pants because he should not have done this. What has happened is he's trying to save money, and all he's done is he's deferred that cost to the future, and now it's your problem. And so from a consultant's point of view, having asset management people on your team actually helps you, because what we often say to the design guys is, listen, this is how you improve your designs, because I've seen what happens in 10 years' time. The problem we have is mostly your design engineers do not see the downstream implications of some of their design decisions in 5, 10, 15, 20 years' time. So the way you do that, I think, to answer your question, is to bring the O&M guys in. And if the client is not requiring it, you should advise him to do that.
That's a very good point. Okay, so I think we've got time left for one last question. Imran mentioned, you mentioned a key factor is to make this policy, and the UK have already instituted this to a certain degree. Are you aware of any intentions in South Africa to follow suit?
Short answer, no. And I think it's a bit of a maturity issue. I spend, as an asset management guy, I spend quite a lot of time talking to particularly government clients. And I think there's a lot of professionals in the organizations who understand and would like this to happen. But I think at an executive level, I think a lot of our particularly government client institutions, they're a long way from worrying about that. I think the answer would be we've got other things we need to worry about in the short term. I think the private sector is probably often better than that, better at getting this done. And there certainly are a number of clients I'm aware of who do require this. And that's particularly true when they're international companies. So they're driven by head office requirements, often out of Europe or the US. So yeah, I'll be honest, I haven't seen a lot of it, but there's a lot of BIM stuff going on, and particularly in terms of BIM authoring, but where we're very, very weak, and even in the UK, I'm seeing it, is the asset, the link to the BIM to asset, and how do you transfer information at the end. That I haven't seen that happen anywhere in South Africa. In fact, the transfer of data even outside of the BIM environment is very, very, very poor.
Okay. Well, I can actually add a little bit onto that. So in terms of mandating policies similar to the UK, if anybody online is willing to read up a little bit more, the CIDB, so the Construction Industry Development Board, is actually working on a BIM mandate for the industry. Where they are currently, they've got a roadmap. So it's good just to keep up with the CIDB to see where they are with that process.
Yeah, fantastic. Thanks for that. Yeah, I didn't know that. Yeah.
All right. On that note, I think we've come to the end of the webinar. Dave, thank you very much for your time and your insights. It was extremely valuable. Appreciate it. And I think we're going to have you back to talk a bit more about some of the other topics. You said you've got another slide or another slide deck to discuss. So, but thank you very much. Appreciate it. And everybody else, sorry, Dave?
Yeah, I think from my side, thank you very much for the invitation. I really enjoyed it. And to all the nearly 200 people that attended, thanks for your time. I really appreciate it. I'm actually quite shocked that so many people think, and I hope that I did do what I was hoping to do and bring a slightly different angle to BIM and really look at the more practical side of it. So I hope that was of value to you guys. And if anyone wants to chat further, yeah, I'm always keen to have this discussion. Yeah, once I get talking, I'm hard to shut up.
All right. On that note, thank you very much. Everybody have a lovely afternoon and yeah, be safe.
Great. Thanks, everybody.
Okay.
Thanks,
Cheers.
Marius. Thank you, Debbie.
Bye.